You know, Craig, there's another way to recrystallize compounds, okay? One that uses mixed solvents. I think that now that the students know the basis of recrystallization, we should teach them this mixed solvent method.
Agreed. Sometimes compounds recrystallize easier using two solvents, one in which the compound is very soluble, one in which it is insoluble. This is a great method. Let's show the students how to do it.
When doing a recrystallization using two solvents, as in the single solvent method, the first step is to choose suitable solvents. Obviously, two solvents are needed. One solvent in which the compound is very soluble at room temperature, a second solvent in which the compound is insoluble at room temperature. The equipment you need includes a selection of test solvents, a glass plate, the compound to be recrystallized, a spatula, and several clean pipettes and bulbs. To select the solvent, you need only a small sample. Place a small amount of the solid compound on a glass plate. Place another sample about 4 centimeters away. Add more solid until you have enough samples for the number of solvents to be tested. Choose solvents of different polarity, for example, water, methanol, chloroform, ethyl acetate, and hexane. Add 3 or 4 drops of one test solvent to one solid sample. Repeat this process for the remaining test solvents, each time adding only a few drops of test solvent to the sample. Examine the samples and decide if the compound dissolved completely, partially, or not at all. In this type of recrystallization, the ideal solvents are one solvent in which the compound is very soluble, in this case chloroform, and a second solvent in which the compound is not soluble, in this case hexane. In this recrystallization technique, the solvent should be hot. Place each solvent in an Erlenmeyer flask. Add boiling stones. Then heat near the boiling points. Place the compound in a tared test tube, that is, a pre-weighed test tube, making sure that the test tube is no more than 1/4 full of solid. Using a pasture pipette, add just enough of the first hot solvent, the solvent in which the solid is readily soluble, to the test tube containing your compound. Here it is hot chloroform. Remember to heat and shake the test tube between additions to help the compound dissolve in the hot solvent. To be successful, you must use the minimum volume of hot solvent, enough to just dissolve the compound, and the solvent volume should not exceed 1/3 of the test tube height. You then start adding the second hot solvent, the solvent which did not dissolve the compound, here the hexane. Add until the solution starts to cloud. As a guide, for this sample size, usually no more than 20 drops of solvent will be needed. Allow the solution to cool slowly to room temperature. Usually, this takes about 20 minutes. As the temperature of the solution approaches room temperature, there may or may not be a few crystals showing in the test tube. Nevertheless, cool the solution in an ice water bath. After some time, usually another 10 to 15 minutes, crystals will have formed. When crystallization appears to be complete, remove the test tube and crystals from the ice water bath and wipe the test tube dry. Remove the mother liquors from the crystals using a pasture pipette. This is easy if you make sure that the tip of the pipette is on the bottom of the test tube. Transfer the excess liquid to a second tiered test tube, since more crystals may be obtained if this solution is concentrated and crystallization allowed to continue. Continue transferring the liquid until it is completely removed from the crystals. A helpful hint: wash the crystals with a little cold solvent, remove the wash solvent before allowing the crystals to dry in air. Record the weight of the crystals and test tube. The weight of crystallized compound is the difference in weight between the test tube with crystals and the tiered test tube.
One of the advantages of this technique is that it can be used for very small or large-scale recrystallizations. In any case, no amount of material is lost in the process. Let's review the steps in this valuable technique.